Hello, I would like to welcome Huilin, who will be presenting her guide on how to find a career path in data science. At Magnimind, we strive to find speakers like this who can deliver talks that are filled with the current information on the industry and give a new perspective on the data science industry to go along with our data science education programs. These programs are designed to build the fundamental knowledge needed for a career in data science, and we aim to impact the careers of as many people as we can, whether it's refining the skills with our mini boot camps or having a whole career change with the support of our mentors. Magnimind has something to offer for any prospective data scientist. Hui Lin is joining us from an extensive background as a data scientist, having worked over 7 years directly in the field for companies such as DuPont and Netlify. She also has her own blog talking about data science, talking about being a data scientist and data science, where she posts guides to data science in both English and Mandarin. Graduating from Beijing Normal University in 2009, Lin received her master's and PhD from Iowa State University, go Cyclones, where she then got her start as a research assistant and statistics consultant. We at Magnimind are extremely excited to host her, and we would like to ask you now to give your full attention to Hui Lin.
Thank you. Good afternoon. Thank you for the invitation, and thank you for joining today. Career is a very personal thing because different people value different things. So what I'm sharing today is really just based on my experience. I'm trying to turn my experience in data science and also my learning during the years. The goal is not to tell you like what you should do in your career. It's more help to provide some different perspectives that can help you figure out what's the best for you. Just let me know if you can't hear me or you can't see my screen. So here is the outline for today's talk. I will talk through different tracks in data science and different roles. Sometimes the title can be confusing, and how data science team is organized, and where you should work, like startup versus mature company. I work for both, so I want to share something about that, and also how to prepare for interview and what to do during the COVID-19. I know it's a very difficult time for people who are thinking about their career. This is the link for the slides. So you can you can get access to the slides for today using this link. So what if you want to know your career path, you need to know what is the path. You want to know the starting point and where you are heading. So if you haven't started in data science, you want to start, you want to know where you should start. And if you are already in the field, you might want to know where you want to go, right? In order to know the path, you need to know what is data science. Data science is one of those terms that's not very well defined. Comparing to 5 or 7 years ago, it's much better today. It's much better defined than 5 years ago. Still very messy. Why? Because data science is not just one thing. If you tell people you want to get into data science, that's too general. Data science is too big. It's a combination of different things. So what is exactly data science? In general, data science actually has 3 different channels, 3 different tracks: engineering, analysis, and modeling and inference. So engineering is the process that actually make everything else possible. Engineering builds the fundamental data and pipeline for everything else. You need to have data to start with to do any analysis and fancy machine learning model and AI, right? And the analysis is the process that you get insight from data quickly in a fast way. It's not about very rigid causal inference. It's more about finding a pattern, some very exploratory, shallow analysis, but very useful. And the third one is model and inference. That involves like statistical inference and more mathematical model. Sometimes it's deep learning and machine learning to do the prediction. So those are the big track of data science. So let's look at engineering in more detail. So engineering has three parts. The first one is setting up data environment. So where you need to store the data, what is your environment that your analysts and data scientists can use to query data, do analysis, all the platform setting, and how you capture the data using Kafka, and how to wrangle big data using Spark and set up all those clusters. So this is the data environment part of engineering. And there's data management part of data engineering. Once you have the environment set up, you need to get the data. So if the data is in the logs, it's unstructured text, you need to parse the log. You might need to connect to different API to get the data, just to set up the data stream, make sure the data flow in with good quality. And sometimes you need to structuralize the data. And then the third one is production. Production can be two-sided. It can be at the beginning of the data stream. When you get the data, it's a production system. And then after analysis modeling, once you have that model, build a model on a sample of data in the research from the research side is one thing. But if you want to put the model into production to be real time at scale, it's totally different thing. If you want to put the model into production, you need to go back to engineering to work on that part. So that's the three big parts of engineering. And on each track, you actually have different jobs. The second big track is analysis. As I said before, analysis is more about getting insight in a very fast way. So you need to know the domain, you need to have the domain knowledge. You need to translate the data to be a story your clients, your end users will take. So you do a lot of exploratory analysis, you do presentation, you do storytelling. It doesn't go as deep, but it's very useful. The third one is modeling and inference. So this track is more mathematical or statistical analysis. It's more technically more math in it. So you do statistical inference. You may design experiment to compare the impact, do A/B testing. And if you are more towards the machine learning side, you will develop model to do supervised learning, to do prediction, or unsupervised learning to discover the pattern, different clusters. In some situation, about 10% of the time, maybe you will do customized model. If there's no specific model that works well in your situation, you might need to customize model. So you do those model development that actually require a lot of understanding of the background of a model. So around different tracks, depending on where you are at, so there are many different titles. Here are some of the titles. I will go through these titles quickly. If you still feel it's confusing, it doesn't matter, don't worry. I will look at those different roles from different lens. Hopefully you will have a better view of it. So data infrastructure engineer, that's the very beginning of the data. So usually data infrastructure engineer is pure engineer. They use language like Go, that's very bottom level language. They also use some higher level language like Python, but they nearly never use R. They don't really use SQL. They handle with the system. So they are very familiar with different cloud systems like AWS, Google, Azure. And they manage the Kafka cluster to do streaming data. And if you go towards a little bit towards the application side, you would get data engineer. That's once you get data from the infrastructure, you will use Spark Scala to aggregate the data, do ETL. So data engineer will use like SQL, and also data engineer is very hardcore engineer. So data engineer need to know or function in the cloud environment. And sometimes data engineer do modeling. That's the old like DBA role. And then if you go further down, there's like BI engineer. BI engineer is not as hardcore engineer as data engineer, but BI engineers still handle with the production system or set up data visualization, use SQL, Python. The BI engineer usually are familiar with a lot of business BI tools like Tableau, Looker Mode, and then that BI engineer is sort of is between engineer and analyst. And data analyst is in the analysis role, analysis track. So data analysis usually use SQL. Sometimes it will be R, Python, depending on your background. Sometimes people know basic stats, and data visualization is a must, and for presentation storytelling. Data scientist, it really depends on what company you work for. So like Amazon has data scientists, research scientists, and applied scientists. Some other company don't have that different title. So in general, just in general, data scientist is more towards R, Python, to do machine learning. And if you are from stats background and become a data scientist, you might do experimental design. So the difference between data scientist and data analyst, the line is not very clear. So if you really want to draw a line, it's more about how much math you need to know, how much statistics you need to know. So for some company, they may have title just like data scientists, but they have / data scientist analysis, data scientist algorithm, things like that. I'm just checking the comment there, sorry. So for research scientists, in some company, research scientist is like the higher, a little bit higher version of a data scientist. Research scientists usually have advanced degree, like PhD degree with many years of experience. They have deeper stats and math background, and they do machine learning. They customize, develop model, and they know algorithm. So if you interview for research scientists, sometimes you need to do some lead code, like data scientists, research scientists. It will be some lead code question about programming. But if you interview for data analysts, usually there's no programming question. And applied scientists, it's more of the engineering version of data scientists. If you are from engineering background, and you can be an applied scientist, that's very similar to data scientists, also research scientists, but you are towards the algorithm. You are closer to production, put the model into production. That require basic software engineering skill. A machine learning engineer, I think that's the most popular one. Because machine learning engineer is different from, it's an engineer, but it also need to know some machine learning model. You have to be able to put that model into the production system. So machine learning engineer need very advanced software engineering skill, because you don't just wrangling the data, you actually need to do complicated model, and you need to make it, put it into production at scale. So that's actually a very high level engineering skill. So if you put everything, if you look at data science as a hierarchy of needs, you can go from the bottom, that's the data science as basic infrastructure. That's what we just talked about, the data infrastructure engineer and data engineer. Those are the engineer that laid out the basic infrastructure for everyone else. And then once you have that infrastructure laid out, you will have data science for human. those will be those analysts, data scientists, research scientists. They will start to do some basic analysis by analysts. And once you know the basic status of your business, what's the key metric, what's the KPI, and then you probably want to explore further how user interact with your product, what's the driver, why people do specific thing. And then you need to answer question about how to intervene to change people's behavior. So those type of questions are data science for human. Usually it's project by project. And then if you build that part up, you can go a step further for go to data science for machine. It really depends on the type of company you are in. You may or may not have that data science for machine. A lot of companies just have data science for human. For data science for machine will either be the company is fundamental a data company, like Amazon, like Airbnb. Those are very data driven company. So they need to have recommendation system. Those system use online data and apply it online. So you have to deploy the model and to apply it online. That's for machine. And some, like if it's autonomous car, it's part of AI and deep learning. That's just totally for machine. So for those type of role will involve both research scientists and also machine learning engineer. That will be the person who put it into production eventually. If you look at different role from a different perspective, like how the data flow, it flows like for data infrastructure engineer, they take care of the data from very beginning. That's the bottom of the different data source. So you might have data in the logs and data is coming. So the logs is generated real time when user interact with your product. So the data coming in real time, and you will have to get that data in real time. You have to decide how to capture it. You can just zip the data every 1 hour or 2 hour and put it in some storage. You want to make sure the data coming in and you keep the data without error, without missing anything. So that's actually a difficult problem if you have many different data sources, always online, real time, and you don't want to miss anything. That's very deep engineering skill involved. So that's what data infrastructure engineer is, to direct and to design all of those, how data coming in. Once the data coming in different data source, you might have data in like S3s and in MongoDB, and also you have data from API. And then how you get all the data together. Data engineer is the one who get all the data from different source. Build up API, you get data from Google Analytics, you get data from S3 that's already zipped, batched data every 2 hours. You get data in, and if it's unstructured, you probably need to parse it to structuralize it and build this internal schema. And this data, so the data from the original source, the data infrastructure engineer handle is very real time, high frequency. And when it gets to internal schema, the frequency is lower, but still quite high. The amount is huge. So there will be a lot of huge amount of data, and also it's more structured than the original source. When you get internal schema, sometimes the data is structuralized. And then you go step further to build conceptual schemas. Conceptual schema is those schema that is normalized. So it has pretty columns and rows, and with specific like foreign key and primary key, you would have a schema to know how to join table together to get the result you want. So that's the schema most of the data scientists and data analysts going to work on for their analytical projects. Sometimes if the data is not in the conceptual schema, data scientists will sometimes also use internal schema, but ideally it will be a clean version of conceptual schema that for data scientists to use. And then for BI engineer, they actually will build external schema. That's the further aggregated data to build dashboard. So BI engineer will work on that level. So, and for machine learning engineer, actually machine learning engineer probably will work all the way. That's why it's very hard to find a good machine learning engineer, because you don't always want to eventually deploy in a pretty format with a dashboard, some type of user interface. You also need to get data from the very beginning all the way through to the top. So now if you look at all those roles again, hope you now have a much better idea what's the difference. For a data infrastructure engineer, usually you don't require very high business knowledge. When you handle the data, you don't have to know what does the data mean. You just want to make sure the data coming in without missing, with right quality. And for data engineer need to know some of the business knowledge, because you are the one to clean the data to be the format that analysts, scientists, BI engineer will need. So you actually need to know what does each column mean, to understand how you want to format the columns. For BI engineer, it's need to know quite a bit of business knowledge, because you need to build the dashboard for business user. Analysts, data scientists, all those need to know a lot about the business, because those roles are the roles that's closer to application end user of the business. A machine learning engineer doesn't need to know too much, because machine learning engineer when it gets to machine learning engineer, usually the model is already built. You know what model you want to build. It's more about how to deploy the model. If you look at production, how close each role is to production system, data infrastructure, data engineer, and also machine learning engineer, they are directly in the production system. BI engineer really depends. Some BI engineer only need to take care of just use the BI tool. So it's not exactly production system, but some BI engineer may have better engineering background. So they will somehow sometimes help data engineer to build a pipeline all the way to the BI tool. So it really depends. Data analysts usually don't touch production system. Data scientists and research scientists usually don't work with production system. It's more about ad hoc analysis or using a sample of data to do the modeling. But data scientists and applied scientists, those are sometimes they will work with production depending on how strong your engineering background is and what type of company you're working on. Applied scientists is more engineer heavy than data scientists. In terms of the data frequency, you're gonna handle, as I said, data infrastructure engineer usually will process very high frequency data, real time, get the data in. And data engineer is also handle high frequency data, but not as high as data infrastructure engineer. In terms of BI engineer, data analysts, and scientists, research scientists, all these roles are not so real time. It's more ad hoc. Applied scientists and machine learning engineer, because they are closer to production systems, so they will handle higher frequency data. In terms of engineering skill, so engineer usually require more higher engineering skill. Other than BI engineer, it's in the middle, because it's the somewhere between engineer and analyst. So the engineer, it doesn't require that high engineering skill comparing to other engineer role. Data analysts usually require very low engineering skill. Other than some ad hoc analysis, you use R or use Python or even just SQL to do analysis. That's about it, about engineering skill. Data scientists and research scientists, some people are talking about educating data scientists to have more engineering skill. I think that's very helpful. It will help data scientists to build the model that's easier to put into production system. In general, they don't have as high of the engineering skill as the real engineer, for sure. In terms of math and stats background, usually the data scientists and research scientists have they have the highest math and stats background. Applied scientists, sometimes if you are if you are sort of like machine learning engineer type of applied scientist, you may not have as high math and stats background as some of the applied scientists that's from more math and stats background. So that depends. And for data infrastructure engineer, data engineer, they usually don't need to have too much math and stats background. In terms of structured data, data infrastructure, data engineer usually will handle both structured and unstructured data. And BI engineer and data analysts and research scientists, the data usually are structuralized. Data scientists, most of data scientists handle structured data, but if you are handling image data or text data, that's possible. In that case, you usually handle the unstructured data for that application. Machine learning engineer, depending on the machine learning model, the source data of the machine learning model, so it can be both. So now you can see all those roles, they are different across like business knowledge production, data frequency, and different requirement on engineering skill and math stats and structured, unstructured data. If you are thinking about data science career, you have to put yourself under this framework to know what exactly is your role, like based on your current background. If you haven't started, you want to find a place to start your career, where should you start? If you are from a pure stats background and you want to be a data engineer, it will be difficult. Or if you want to be a machine engineer, it's very difficult. If you are pure computer science background, all of a sudden you want to be a data scientist or research scientist, it may be harder. You can also, if you want to get to that role, you will know what type of knowledge you may want to learn to get yourself there. So most of the people you see in data science focus on one track. Like I'm more of a data scientist person or research scientist type of people. And there are very few people that are good at two tracks. You will do, like, you can be a data scientist that do some engineering work, or you may be better at engineering than other data scientists. You write better code, but in general, it's very difficult to find someone that is expert on two tracks. If you know anyone that's expert on three tracks, that's just a unicorn. I haven't seen any person like that. So that hopefully so far that gives you a better picture of what data science looks like, what's different role in data science, and give you a better idea of where you should start, or you may start to think about what's your next role, what you want to do. And there's a career path in each track. You don't have to switch track. They're usually, like, if you are in the analysis track, you can go all the way to chief analyst or staff analyst, principal analyst, similar to data scientists. You can go on that track. You don't have to switch to another track to climb up. So then, where does data science belong in the organization? So there are three different ways to organize data science team. The first way is a standalone team. It's easy to understand. Just data science is its own team, parallel to any other teams. This type of organization usually is in smaller company, where data science is in its own team. You have engineer, analysts, and a couple of data scientists in its own team, and you might have a chief data scientist or a head of data science that report directly to CEO or some very senior level in the company. So the pro of this type of organization is data science is has its own autonomy, and it's well positioned to tackle the questions and also set its own priority. It has its own freedom to decide how you want to develop, how you want to tackle the project, and what's the priority of the project. And it's easy for people inside the science team to share knowledge. And it's also very attractive for talents because they will feel like there's a career path in a standalone team. But the risk of this type of team is the marginalization, because if you are a standalone team, the downside is you may be further away from the application. For example, if you are supporting, you are doing analysis modeling of user behavior interacting with product, the ideal case is you work closely with product. In a smaller company, it's easier. It's usually not a big issue. But when a company gets bigger, usually different team, they have different barrier across team. So you are under the risk of, you work in data science team, you can't really be close to product. That's where data science is actually used for. So what you will see more common is when a company gets bigger, they will tend to break the data science team to be in different team, or at least closer to the application. So that will bring you to the second part of organization, that's embedded model. Means in this model, you still have a data science team per se, but it's more from a people managing point of view. It's like the person is responsible for performance review, and as hiring manager and coach or technical coach. But you as a data scientist analyst working in that team, you will actually be farmed out to different team. That's your daily work. So the pros is you are closer to the application. So you actually work in the product team. And it gives a lot of flexibility of the application of data. So data science can work with many different teams and just farm out the talents to different team. But the concern is it's harder to attract people to this type of organization, because the people who give you review is different from the people who actually work with. So these two don't align, that will cause some difficulty. And also, since you work in that team but you are not really part of that team, that could lead to a situation that data scientist becomes a second class citizen everywhere, because you basically don't really belong anywhere. So the most common, as the company grow, the most common way that data science is organized is as an integrated team. Means you fully integrated into different team. For example, the product will have data analysts and data scientists in product team. And marketing will have its own data analysts and data scientists. Sometimes they even have their own like data engineer. It's fully embedded in the team. So the advantage is very obvious, because you can actually align the application very well. You actually integrate the talent into the application where data science is used. But the concern is you don't actually have a data organization anymore. So what's the career path of the data scientist in the team? Because the data scientist cannot be a marketing manager. Then what's the career path of the data science team? I think it's more of a concern in the company that data science is not as big as in some other company. If for company like Google or Facebook, it's really data heavy. So even you are individual contributor embedded in a team, you still have a career path from data scientist to senior to staff, probably to principal. So that's not a concern for those mature data oriented company. It's more of a concern on the company in the middle. So you see some data scientists, analysts change company for that reason. Just there's no career path. So then we talked about different tracks and how data science is organized, and it also the way it is organized also it's also impacted by the size of the company. Then one question often comes up is what stage of the company should I join? Like, should I join a startup or should I join a mature company? So this is not a question that's easy to answer because, as I said, the career is very personal thing. Different people value different things, and the startup and the mature company, they provide different benefit and they have their own concern as well. And I will just walk through what I, based on my experience, what I see and what's the difference between these two type. And it's you gonna decide what you want, what's best for you. I worked at DuPont for 5 years, and I worked at the current startup for 2 years now. And when I joined the startup, it's Series A, and we only have 20 something people, and now we are about 100 people. So it's quite a journey to see the difference. So for if you work at a startup, usually you wear different hats. That's easy to understand because there's not enough people. And versus if you work at the mature company, you have more well-defined role. Like when I was working at DuPont, I'm not just a data scientist. I'm also a data scientist in marketing, even in North American marketing. So it's very embedded and narrow role. So the method you use can be very limited in terms of well, after I joined a startup, it's over the board. Sometimes you do something you didn't even dream of before. You just need to wear different hats, whatever it takes. And the second thing is, at a startup, you got to learn end-to-end process. In a mature company, because you work for a very specific role, which means you sometimes you don't see the whole forest. You are very good at the spot. Like I never saw where the data comes from. From my point as a data scientist in a big organization is I have a database already there, a very clean schema. So I have no idea how the data flow and how it gets to production eventually. I just work on my part. Versus startup, you basically have to get data from very beginning. Especially when you join a company, if a company doesn't really have a database for data scientists, you have to dig it out from the very raw source, and then to clean out the data, and you need to deploy it yourself. So no one will help you to deploy your result. So you do see the process end to end, but you don't go deeper at each point because the company cannot wait for you to go deeper. You always on the go. So you make something workable and then you move on. And you hear the word burn rate a lot because startup need to raise money. So a lot of the planning, the strategy is around what's the current burn rate, how much money we have, and how long we can last based on the current burn rate, and when should we raise the next round money. So you are always under the pressure. So that's something you have to prepare. Versus you work for a big company, you never it's you have a lot of resource. You don't actually think a lot about running out of money. And you get in a small company, you get to decide what you gonna to do. Basically, you are the one who define it. When I joined a startup, there's no data platform, so you're gonna to start from pick a data environment. So you're gonna to decide what to do and how to do it, what's the best way. Versus in a big company, you have to start by following what's the current status, what's the current best practice, what and how to do things. Maybe at some time in the future, you will be able to do some innovation, but first it's less likely. Second, even it happens, it may be slower. Um, And you feel in a startup, you feel you are very important. I know many people in startup world, they enjoy that type of feeling that you are important, no matter if it's, I think for any organization, other than if you're not the co-founder, the organization will probably be okay without you, but you can't deny that you actually see your impact right away and you feel you are important, indispensable in the organization. Versus in big company, you actually are indeed dispensable. If you leave the company, they will easily find someone to replace that role. That's just the way big company is. And in small company, you have very limited mentorship. You actually have to decide what's best for you. You don't always have someone tell you what to do and mentor you. But in big company, you can find, sometimes you can find a very good mentor or role model. That's something I miss a lot by joining a startup. In startup, you have to bear with ambiguity and frequent change. Versus big company, it's more stable, and you have clear direction, roadmap. And of course, from the benefits, the salary, startup usually they pay lower than market value salary, not as good as big company, but they do pay very generous equity, especially depending on when you join the company. If you join earlier, the potential is higher for sure. If you join later, because it's option, you need to pay more to buy the option. So, and there are a lot of intricacy. It's another thing. It's another story. So I won't go into too much detail about startup option. But one thing I do want to say is, some people say it worth nothing. You have to treat it as zero value. I don't agree with that. It certainly has value. Sometimes it's significant. It's in terms of money value, it can be significant. It's a matter of when you join the company, and how the company developed. But if you join a startup, you buy a lottery ticket. That's something you just have to be clear to start with. And startup is not as stable. And bigger company provide better security. And startup doesn't have give you the brand. I certainly sense that when I work for a big company, when I versus startup, when I go out to give a talk or a presentation, workshop, you feel different. People don't recognize the company name. Um, and startup moves fast and big company moves slower, and less hierarchy in startup. If you are the type of person don't like red tapes, the hierarchy, management, startup may be a good place for you in that sense. Bigger company will have more rules, and startup is more flexible in terms of time. You need to work a lot at startup. That's, I think in general it's true, but you do have more flexibility in terms of when you work, and work from home or work in the office. Not because the virus in general. I think my current company is very, very remote friendly. And regardless of the stage of the company, there are something I want to point out is, even every company will claim to be a data-driven company, but they are still different. That's something you need to find out before you join a company. I will show two examples here. It's not good or bad. It's more about what you are looking for. So for this example, you can spend some time read the text, but in general, what you can feel like, if you read this, the team have much to learn from DevOps. It just, what you can feel right away is, at least I will feel, it seems data is not, it's like secondary. I'm not saying you shouldn't learn from DevOps, but it seems like it's engineer heavy company and data is very secondary, and it's not they don't use data in a deep way. I don't think that's hard to figure out here. And it also says the team will, eventually the team will include data scientists. That means they only do basic analysis. And it seems to be a company that's very heavy in engineering. So what it tells me is if you are a person that has heavy engineering background, but not that deep in math or stats, and somehow you are very interested in doing data analysis, this actually will be the perfect company you can join. But if you are someone like me from the math stats background, and very into machine learning and stats model, and don't have that deep engineering background, I don't think this type of organization will be a good fit for me. And versus it's another company. I was thinking that I should just hide the name, but it's very hard because it's Airbnb. It's a company I really like. And just because the tool, the text mentioned the tool, if you look at the tool, you will know it's Airbnb. So I didn't bother to hide the name. But just by reading this paragraph, you will feel like they actually do data science, not just data team. It's actually a data science team. If you are a machine learning engineer or data engineer or research scientist, data scientist, I think this will be the company that, at least from, I don't know about the culture or the management environment, but just by reading the professional, the data science as profession, I feel like it will be a very good professional environment for you to grow professionally. So I think a good way to, before you join a company, if you want to figure out what type of role data plays at that company, you can go to check their blog, how they describe data science team in their company. I think you will have a lot more idea after those research. And other than that, so I have talked about different company are different, even they all claim to be data driven, and you want to do some research to know exactly how this company is driven by data. And the third point I want to make is team actually matters. Even inside one company, different team can be very different. So one difficult thing about it is it's very hard for you to figure out before joining a company if it's a good team. A way you can do is to talk to the team members or hiring manager to try to figure out the culture of the team, the personality, and what's the daily life is. But the manager and the team matters the most. Product matters, but you don't join a company because of the product, because in the end of the day, you actually work with your team member the most. You don't, those people say you don't leave a company, you leave your manager or you leave the team. I think that's true. And also, if you want to be Google employee number 20, of course, you have to join Google when it had only 19 employees. It goes back to startup versus big company. If that's what you want, you basically have to join a startup. So then how should you prepare for an interview? So I want to go to the detail about what's the technical material you want to prepare. It's like go through lead code and how much time you should spend on lead code, machine learning material. First, it really depends on what type of role, as I show you in that list of role and where different role drop in the hierarchy of data science and a data flow, and what's the required skill for different role. You need to prepare different thing for different role. So that's very different. And there are a lot of material online you can search for. Once you know what role you want, you can search for a specific type of role and how you prepare for it. And here I just want to tell you what's the general process I see in data science. Usually you will start from the recruiter, and then you will have 1 or 2 rounds of technical interview. And those technical interview will usually have that online coding, whiteboard coding. And then depending on the company, you could have an on-site interview. And now it's video because the virus, it's all video. Or you can have a take-home exam. So I won't go to detail about the interview process because different company might have slightly different interview process. But I want to talk a little about some of my thoughts around going through the interview process. The first is you don't think if you are not experienced you can't find a job. It's not all about how experienced you are. It's more about if you are a good fit for that position. So if that role is entry level role, the more experience you have doesn't help at all. And also if that if that's a role from a pharmaceutical company, for example, and they may even they are hiring a data scientist or analyst, they might need you to have some background in biology or medicine. So it's even you can have very deep stats background or coding background doesn't mean you are a good fit. So all I'm saying is it's about fit. So if you fail one interview, don't lose heart, just moving on. It may not be the right fit for you, and learn from each interview. And also there's certain amount of luck in it, depending on who you are interviewing with and what's the question. Sometimes you might have seen that question before, and sometimes it's totally some question you're not familiar with, especially for company that with general hiring, like Google, like LinkedIn. If it's general hiring, usually you will expect question from every different background. So you could have some question about database design or stats or even coding. So it's everywhere. It's a lot of, I think for that type of interviewing, the amount of luck is higher. So you just need to try more positions. And also the job searching is a very process, and the emotional roller coaster feels bad. You just need to hold on and moving forward, don't lose heart, and you are getting better each time. You just learn from each interview round and you will get better. It's just like interviewing is about it's like muscle. The more you use it, the better you will get. I even heard some people, they even they are not actively looking, they will interview for some position from time to time. First is the interview to know the current market value. If you have working at a company for a couple of years, you might not know your value right now at the market that well. So interviewing can help you understand what's your value now. And also it's very good practice. It's good to keep yourself being competitive. But it just some people think that way. There are some people they're just pretty happy within a company if a company provide very good career development and very good career path. So it really just depends. Now, what to do during COVID-19? I'm not going to sugarcoat the current situation. It's difficult. It's not just for hotel or the service sector. Eventually it will impact most of us. But I think the silver lining is you actually realize there are things that are way more important than your career. You probably spend more time with your family. You get connect. You start to appreciate things you probably missed before. But under this situation, how can you prepare for your career? So you have to get used to virtual interview, or you have to learn the skill of working remotely. Even after things settle down, I think there will be some permanent impact on how people work. There will be more company that support remote working. So get used to the virtual working environment becomes important. And also think about short term. It's when things are highly uncertain, it's not very helpful to think about long term. If you are, depending on your current situation, just focus on now, today, what you are going to do in the next 1 week, 2 weeks, 30 days. Don't think too long about the situation after half a year. Um, and if you are right now on the job market and there are not so many opening, you can take online course to sharpen your skill during this time. Of course, well, think short term, as I said, just improve your skill at the same time. Um, and you can consider some of the company that ramping up hiring or even um, just keep on their hiring. Like some big company, they are still hiring like normal, and some company like Zoom, Trader Joe's, they actually ramp up their hiring and be an efficient remote worker. I talked about get used to the virtual interview world. And also, I think one point probably people will miss is maybe you can reach out for help. You will be surprised how people are willing to help. Just reach out to people, ask people who have experience and more experience than you, what's if they have any suggestion. You can send out email or LinkedIn message. Don't worry about bugging people. People are happy to help if you ask. I think that's all I have today. Any questions?
So if you go into the Q&A tab, there's already about 3 questions. And anyone else who wants to ask a question, make sure to go into the Q&A tab and just type it in right now. I know I saw a lot of raised hands.
Oh, I see that.
Yeah.
What percentage of data science jobs do you think are advertising related? I don't, be honest, I don't know the percentage. I have never worked on advertising. I know there are a lot more that's not related to advertising. Like when I was at DuPont, I don't know anyone that's worked on advertising. Advertising is more for those internet related company, I think. To me, the biggest issue is not having skill. Oh, for people who are more interested in how to find a job in data science, it's really depend on your background. I got a question asked it not too long ago from the friends that he knows someone that's with law background and want to be an analyst, and ask what type of like data science program she need to go through to be an analyst. It's totally different field, but she's interested in data. So I think my suggestion is focus on your background and do analytics in that background. Like you can go through, there are many different data science bootcamp thing. Go through the basic skill and find a target for the job in your application background. Like you can target in some law related analytics. If you are not totally from relevant background like stats and computer science, and you want to be in data science, sometimes it's harder, and it's easier for you to start from the area you are closer to and become an analyst in that area and go from there. Could you type the link for us? What link? Do you mean the link of the sites? Oh, that's the link of the sites. Oh, now, yeah, that's the link of sites. Yes, I can send it out later. Oh, so what track do you recommend for preparing to become a machine learning engineer? Of course, data engineering track. Machine learning engineer is still hardcore engineer. Like for people from my background, it's very, very difficult for me to be a machine learning engineer. Especially if I want to be a machine learning engineer for those AI product, it's very difficult. It's a big change. Oh, I still have to pay bills. I actually don't quite know that question. How do I find companies that are ramping up hiring? If they are hiring, I think they will have posting online, and if you search online, there are some article on what company are hiring. I used to find a very good. So someone I can look for it again. Someone actually get all the information together. They have a whole list, hundreds of company, actually thousands of company, and which company are hiring, which company has freeze, which company has lay off, and they list it out. You can filter by the company name, different categories. Quite amazing. I saw that at some time point. But if you Google, you probably will find it too. Is data cleanup part of data scientist? Yeah, data scientist is, people would think data science do fancy work. I spent 60% of my time just doing cleaning. Sometimes it's very, very tedious data cleaning. I think that's the major part of data scientist. And it's data cleaning is like across tracks, no matter which role you have. You spend a lot of time. Oh, example of resume for data analyst position. I don't have any example of resume for data analyst position. I think that's just general. It's not specific about data analyst. It's general resume. What's the best practices of making a good resume? What type of data science work who are involved in legal, risk, and compliance for privacy and security? I actually don't know what type analysis. I know there are some people working on it, but I don't know exactly what type of it's not data science work, it's more analytics work. What's your suggestion for someone who has no data science education, but now is trying to switch to the area? Yeah, I said you have to start from your background. See if you can get to the closest. Take advantage of your previous background. In terms of get back to school or boot camp, that's not easy. I think, well, getting back to school is very expensive. It really depends on if you can afford it. And it's not just about money, it's also about time. In that sense, I think boot camp may be a better choice. And it's also depend. I know a lot of people that have a PhD in some of the area, like biology, chemistry, physics. Boot camp definitely will be a much better choice for them instead of getting a degree in computer science or stats. highest paying, I think it's a machine learning engineer. Well, you have to, so if, for each track, you can go from like entry level to very advanced level. So you can compare that way, because different level, in different track you have different level, but just based on specific level, I think machine learning engineer right now is the one paid the most, because if you actually look at requirement, it's required the most. Machine learning engineer need to be heavy engineer and also know the machine learning model. So it's hard to find skill, especially when the model is complicated. You want it run at scale. It's not an easy thing. If someone wasn't ready to get a job in data science because of the need to explore the range of data science category, how could they work in a sandbox environment to see what really resonated? That's a good question. For me, I tried a little bit different thing during my work. If you don't really want to get a job, maybe there are some open source project you can participate, or some competition. So there are some data science competition, and also there are different hackathon. I think that will be a great way. There are some hackathon around data science. You work with people, so that's a very good way. Usually the question from the hackathon is real applied question. So that's a good way to have a sense of what you like to work on. In my current company, since it's very small, we have a centralized data science team. So in a data science team, we have one engineer, one data engineer, one BI engineer. I'm sort of the manager. I'm the manager and data scientist in the team, and we have a data analyst. So that's how the team is organized right now. And we are still very small. And data infrastructure engineer is not part of data science team. That's too heavy in engineering and very close to the infrastructure and backend. So it's not in data science team. That's how it's organized right now. We are still planning. So certainly there will be some hiring freeze, but we still don't have, right now in terms of engineering, data science, we still have a plan yet. It seems so far we're not impacted, but you never know how things go as it develops. OSSU, I actually don't know. I don't know that that program. So I can't tell you if OSSU data science is good to start. What are the best resources for data scientists who works with algorithms? How can I learn database related to data science and web programming? So database related, most of the data scientists I know don't know too much about database. It's more towards data engineering. The best way to learn it is by working on it, to be honest. If you are already working at a company, it's better to collaborate with some project that involve that skill and just apply it. Oh, transparency, unbiased output. There's legal team, both in my previous company, it's more mature. So there's legal team and privacy people. There's a lot of privacy rules around. And at the current company, we have security people. That's in another team, engineer set of security people. Research scientists without PhD. Not every company has research scientists, but very rare. Yeah, very rare. Usually research scientist has a PhD degree. Which typically require an advanced degree. Research scientists typically require an advanced degree. Data scientists usually used to be 5 years ago when I started, most like, I think based on the survey to start with, it's like more than half have PhD degree. But now I think most of them are master degree. Data scientists, most data scientists are master or PhD. There are some bachelors. But research scientists certainly are most PhD. An engineer, I don't think engineer require, if it's engineering role, working experience is more important than degree, except for AI. I think for AI, degree and your education is still very important for that specific field. If you want to do research and build data product. Which role finds the data? I actually don't know what do you mean by finds the data. Basically, the data is collected. It's the infrastructure will design the data capture, and it's the evolving process. Like product manager might talk to you about, I want to solve this problem, and then you will go back to your database to see if you have that data currently. If you don't have, you will go further back to infrastructure, ask them, do we capture that data somewhere? And then that's how we kind of find the data. If the data is not captured anywhere, then it's another conversation about how can we capture that. What do you suggest for someone pivoting from marketing management, 20 years, that's a long time, to data science? I'm currently studying Python, R, SQL. Do I need to be a data analyst before becoming data scientist? Yeah, I think so. I knew someone is that way. I think in my previous company, it was the biggest concern from people. It's the many people want to be research scientists, but it's like a hidden rule. As I said, if you don't have PhD degree, they won't promote you to be a research scientist. Even just title with scientist. It depends on the company and the culture. Some company it's not very likely, but some company might have exception. But starting from the data analyst is a good choice. You can target for a marketing team. My previous company, when I work in marketing, there are many analysts they actually like people from marketing background. That's what they are looking for. And the analyst in my previous company, he ended up to be a data scientist. So it's possible. Any tips or thoughts on career change from IT operation to data analyst? My current company has a role called infrastructure analyst. I think that might be a possibility. I don't know. It's not in my team. It's in the infrastructure team. But that's basically analyze data from infrastructure. That's what I mean by you need to get some role that's closer to your application. Normal data analysts from stats background cannot do those type of analytics. It's not because they don't have analytical skill. It's more about they just won't be able to understand that data. Even I don't do a lot about those infrastructure data. It's a data environment. Data context is very different. if you have skills which don't match specific job descriptions, but that overlap different job descriptions, do you have any advice? I'm in a startup and looking at medium to large companies. Uh, For the job description, based on my experience, I don't think the job description, it's just a general framework. As long as you have significant percentage of overlap, I think you should try. Because what people are looking for may change after interview. Being an ex-assistant professor in computer department, what specific skills I should acquire to become a data scientist? I think data science area is taken by computer scientists and physicists. I always think that way. People from stats background, I think it's not the majority of data science. Computer science is, right now we don't really have a data science degree per se. I think computer science is actually the closest to data scientist. Maybe you can get more math and stats skill if you are from computer science background, but you should be in a very good position. Is there any way I can work as a data analyst for part-time at the beginning? If yes, where is a good place to work for this type of job? Intern? I can't think of part-time analyst. Maybe from intern. There are some part-time intern. How important is develop like Docker, etc. for data scientists? Before I joined this company, I don't even know what is Docker. Now I heard that word enough times. I sort of get familiar with that word, but I still don't know exactly like what does it do. So I guess is that not important? Just don't really use it. You can be if you are an engineer, like machine learning engineer, you probably will use that a lot. Data science book. There are so many books. I think you can, I don't have anyone. Well, there is a statistical learning. That book is very good. It's by a professor from Stanford, I think. People call it Data Science Bible. You should check that out. And if you want to improve the programming skill, the best way is to read code. I do find that's helpful to improve programming skill. Publication. I actually don't think publication in good journals gonna help. I actually think that's something need to be changed because PhD degree, well, you can't close the door for people who don't have that degree. That's what I think. But I don't think publication will help. But what you did before certainly will help. I mean, exactly the type of research, the hands-on analysis you do. What's the percentage of data science versus every data engineer's job? I think there are way more data engineer job than data science. I don't know the percentage. I have heard the most common is like 5 engineer, 1 data scientist. If you think about the hierarchy, that makes sense, right? You need to have a lot more engineer to build the infrastructure, and when you hire data scientists, it's when you have that infrastructure up and running, and you need people to maintain it. Yeah, that's what I heard. 1 to 5. And my current company, I think it's reasonable. Data science like books, videos, blogs, there are too many, and they are all very similar, to be honest. Because in terms of those skill, it's very defined, very well defined in terms of the skill. If you are sure what you want to do, what type of role you target, I think the material is not hard to find. It will be difficult if you don't have any target in mind and just general want to get to data science, then you don't even know where to start. I like Coursera. I still take course from Coursera. So we can look for some data science specialization in Coursera. There are some good course there. ML modeling. Oh, ML modeling from actual coding versus using ready to model like H2O. Well, you have to know when you can use H2O, big ML, those you already have very good idea of the data. Think about what they need. They need the training data, and they need training X, they need Y, right? But a lot of the current work, that's even just to figure out what should be X, what should be Y. And a lot of work is not related to machine learning. So once you have clean data, I do think those auto ML is the way to go. There are a lot of questions around. Now we have auto ML. Do we still need data scientists? We still need data scientists. We need people to frame the problem. Oh, what was that book by professor? Let me see if I can just. I actually have a GitHub repo that. Let me find it. I put together the material I think is useful when I'm learning. So I will see if I can find that link for you. Apply statistical learning. There's an online PDF version that's free. It's called an Introduction to Statistical Learning. Let me see if I can. Oh, wait, sorry. Type answer. So this is the. Oh, I just realized I can type answer. Hope you receive it. I'm not quite sure. I can't tell from my side if you receive it. But that's the link. This is the link of the book. So this is the book. It's very good. Respected as dictation, Harvard's program EDX. I don't think so. I actually don't know if there's a program that give you more credit because of the big name. Yeah, that's a really good book. And there's more statistical one, more theory. I think that's elements of statistical learning. Yeah. Yeah, the elements of statistical learning. You can actually see the PDF version. So this one has PDF version too, and this one has all the code that you can repeat. So it's very good. It's more applied. This by the same author. This one gets into the detail of theory. So most people will not need this book. If you target for some research scientist position, you may want to check out this book. But the applied one already very very theoretical for most of people. I think that's all the questions.
All right, great. Well, if we don't have any more questions, we can just go ahead and wrap it up. Thank you so much for giving us your time, Hui, and thank you for everyone else to attending the talk. Magnimind holds these in the hopes to inspire people to further their learning, and all of you, if you came, you did that today. So good job. We also hope you'll join us for our next talk on April 22nd, machine learning in databases, learned indexes, hash tables, and B trees. Thank you and have a good day.
Thank you. Bye-bye.